Today we're going to be doing a video on the mean value theorem. If you haven't watched my other videos, you need to go watch them, taking the derivatives, Newton's method, all that other stuff. It's not the exact same thing, but different concept, somewhat the same. Basically, what the mean value theorem says is, if f of x is continuous over a and b, then f prime c is equal to f of b minus f of a divided by b minus a. What does that mean is that on your x and y graph you have a point A and a point B. And in between these points you're going to have a point C. You want to try and find that midpoint that is still over the interval that you are given. There are going to be some instances where you're not given the interval and you actually have to find the interval yourself. But for the majority of the part, depending on your professor, they may or may not do that. The majority of the time they're not going to do that to you, they're just going to give you the interval. And when they do that, you're going to set your second coordinate to equal b, and your first coordinate x is going to equal a. Y is equal to b, x is equal to a. And you're going to plug them into this formula to find out where is c, and remember, it has to be in between those two intervals. It cannot be any less or any more than what's in between your intervals. What you're going to do is you're going to calculate using the mean value theorem, using your original equation, whatever it is, plugging in your two intervals. After you do this, you're going to take the derivative of the original function and then set it equal to whatever you got using your mean value theorem, which is this formula right here. After you do this, you're going to solve, and like I just told you, you're going to keep only the intervals that are in between your two given intervals. It cannot be before or after, just in the middle. So a quick example of this. So I've been given the function x cubed. Okay, you can kind of cheat and go ahead and take the derivative, in which case x cubed, you know, your exponential rule. Break it down, you got 3x squared now. That's your first derivative. You have been given the interval 0 and 2. Like I told you, you're going to go ahead and take these intervals. This is your b, I'm sorry. This is your b, and this is your a. You're going to plug b and a into the mean value theorem, FB minus FA, B minus A. What that F symbol means is that you're taking your B and your A and plugging it into the original equation. In which case we're going to go back over here. The original equation is x cubed. So, imagine 2 is now x. You have 2 cubed minus, remember your A is 0, so it's 0 cubed divided by B minus A, which is just 2 minus 0. If you solve this, it's going to be 8 minus 0 divided by 2 over 0, which is just 8 divided by 2, which is just 4. There you go. Now, that just solved the first instructions. So now, you took your first derivative, and now you're going to set your mean value theorem to equal your derivative, vice versa. Take your 4, get your 3, x squared, divide by 3 to both sides. That leaves you with x squared is equal to 4 divided by 3. And in order to get rid of this x squared, you're just going to take the square root of both sides. So now your x is equal to radical 4 over 3. You can use the mean value theorem for different intervals. It can be nasty, it can be you can be given intervals within rational functions. There are so many different things you can use the mean value theorem for. Go watch my other videos, and I will see you later. Just a recap of what we did. We calculated using the mean value theorem, original function b minus original function a divided by b minus a. Once we figured out what our MVT value is equal to, we took the first derivative of the function and set it equal to what we found by using that. And then we solved, and in most cases, you're going to get more than one answer. It's going to be a plus or minus answer. which actually, if we go back over here, that's actually plus or minus. I do apologize about that. We're going to keep the positive, because if you look here, our intervals was just 0 and 2. The negative value wouldn't have worked because it would have went past 0. And like I told you, you don't want to do that. So, thank you, and I'll see you later.